This video is going to cover creating tools in Sheetcam. You can see here that I have 2 tools created, and then I have 2 code snippets created. Code snippet is treated as a tool in Sheetcam. To create a new tool, just go to the icon that says create a new jet cutting tool. I usually leave the automatic generate name unchecked. I like to name my tools. For quick glance, I can tell exactly what tool it is. Sheetcam tends to name them by their kerf size. I name them by the thickness of material, the type of material, and the amperage it's cut at. So let's create a quick tool for 16 gauge with a 45 amp plasma cutter, a Hypertherm PowerMax 45. So I go 16 gauge steel, 45 amp. It is a plasma tool. Tool number, I let it default. Kerf width, there's an estimated kerf width chart in your Hypertherm manual. I found that the best way is to actually get everything set first, put a number in here. I usually start with 50 thousandths, get everything set, and actually cut a piece out and measure it. Bear in mind that your kerf is going to change as your consumables wear out. Lots of things affect kerf, so I'm not saying it's not important, but trying to get it down to a thousandth of an inch only to find out the next day when you cut it's going to be a little bit different. I'm going to leave it at 50 for this. Feed rate, I'm getting all of this information right from the cut chart in a Hypertherm manual. Feed rate is 350 inches per minute. Pierce delay is 0. Pierce height is 0.15. Plunge rate is not in the Hypertherm manual. Plunge rate is the feed rate for the z-axis going from pierce height to cut height. I typically leave it at 30. Really thin material like this, we may, at 350 inches per minute cutting, we may have to bump this up to 50 inches per minute. Very thin material like 28 gauge, I usually pierce and cut at the same height, so I don't have a plunge rate. I'm going to leave this at 30 for now. Cut height is, according to the Hypertherm manual, 60 thousandths. Pause at the end of the cut. I like to leave that at a half a second. You can play with that and decide what works for you. I prefer to leave it at half a second. Preset volts, right from the Hypertherm manual, should be 116. DTHC delay, this is the time in seconds before the torch height control will kick on after the torch is fired. Typically we want 1 to 1.5 seconds. If you're cutting really thick material and you start getting pierce delays of 2.5 seconds, you're going to want to up that to 3.5. But typically any setting between 1.5 is sufficient. No DTHC is a 0. So if we put a 0 in here, this tool, every time we use this tool, it will automatically shut torch height control off. So use this cautiously. Bear in mind that you can do that, but you might want to name it up here no DTHC, so that we know when we choose this tool we're not going to have torch height control. By default it's 1, which gives us torch height control. Lead-in type, that is the piercing, normal, ramp, or wiggle. I typically use normal. The only time I use wiggle is on very thick material that basically Hypertherm says you should be doing an edge start on. We choose OK, and you can see here that we have a new tool created. And that is all there is to adding plasma cutting tools. Very similar if you have a scribe. Well, first you select that it's a plate marker, give it a name. One thing to remember is the plate marker needs to be, the tool needs to be greater than 100. That's how the computer knows to apply the appropriate offset. Center point is always your torch. When it calls for any tool greater than 100, it'll automatically add however far to the left and to the rear the scribe is, so that it'll still be based on the same 0 point. So that's very important that we create a tool and the name is greater than 100, the number is greater than 100. Diameter, that's a variance of the tip you have and the amount of pressure being applied. I typically scribe everything with no offset, so diameter's kind of a mute point to even enter, but let's put 50 thousandths in. Feed rate, I typically scribe it around 60 inches a minute. Cut height is 0 because we're not cutting. Start delay, that's the time from the time the solenoid fires until the cylinder drops down. That's typically about 1.2 seconds. Pause at the end of a cut. We want that to be fairly high because we want the cylinder to actually retract all the way before motion starts. So don't be afraid to set that high, and you can fine tune it later. I typically put it at full 2 seconds. And you can see now we've created a plate marker tool. So similar to our last video, if we wanted to cut this out but we want to describe that circle, we would just choose inside, we would just choose that particular tool, and I will do no offset. Now it's going to scribe this circle, automatically apply the offset, then it's going to stop, the scribe's going to go up, the torch is going to move over to here, and it's going to plasma cut this piece. And that's it for creating tools in Sheetcam, and you can have as many as you like with DTHC, without DTHC.